JavaScript internals. How the event loop works. You've heard that JavaScript is single-threaded, but non-blocking. But how can a single lane of traffic handle so much without a perpetual traffic jam? This isn't magic. It's a system called the event loop. In the next 3 minutes, we're going to visualize how the call stack, Microtasks, and Macrotasks work together to make JavaScript's asynchronous magic happen. The core components. First, let's meet the key players. The call stack is where JavaScript runs its code, one command at a time. It's a last-in, first-out system. When the call stack encounters a task that takes time, like a setTimeout, it delegates it to the Web API, which is a set of tools the browser provides. The Web API handles the task in the background. Once the Web API finishes, its callback function is moved to a waiting line. There are two main lines: the Macrotask Queue for things like setTimeout and user clicks, and the high-priority Microtask Queue, mainly for promise callbacks. The event loop gives higher priority to the Microtask Queue. The event loop is the manager. Its job is to check if the call stack is empty. If it is, it first processes all tasks in the Microtask Queue, and only then takes one task from the Macrotask Queue to run. Visualizing the code. All synchronous code runs. Console.log start execution goes on the stack and logs start execution. Then console.log end does the same. During this, setTimeout is handed to the Web API. Its callback is placed in the Macrotask Queue. The promise.resolve.then is also found, and its first callback, promise1, is placed in the high-priority Microtask Queue. Now, the call stack is empty. The event loop checks for work. It sees the Microtask Queue has a task, so it runs the promise1 callback. But that first .then creates another promise, and its callback, promise2, is immediately added to the Microtask Queue. The event loop must clear this queue completely before moving on. So it runs the promise2 callback. Finally, the Microtask Queue is empty. The event loop now checks the Macrotask Queue, finds the setTimeout callback, and runs it. Synchronous code runs first, then all pending microtasks, and only then does the first macrotask get its turn. If this visualization helped, give this video a like and subscribe for more deep dives. Thanks for watching.